So in learning module 1, we looked into the problem formulation process, right? So in today's class, we will look into 3 different examples and put that problem formulation process into practice. Okay, so the agenda is very similar to what you see in your syllabus. Okay, so for each of those problems, what we will ask ourselves is, can we identify a problem statement? Okay, so that's the first piece of the puzzle. Okay, based off of that problem statement, we'll look at a 30,000 view of the problem, and then we'll look into a more detailed structure of that same problem from a conceptual model standpoint. Okay, and then while we are doing that, we'll of course look into the type of the variable that will eventually dictate the kind of problem that we are looking at. And we have actually discussed all of these in learning module 1, right? The kind of quantitative versus qualitative and so on and so forth, and how they differentiate. And then once we look into the problem formulation process again, as well as some of the subsets of the problem, we will be able to start looking into the kind of inference that we may be able to draw from here. I do not want any one of you to start thinking number crunching at this point. Take a step back from numbers. Take a step back from, okay, I want to do this kind of a test, that kind of a test. No. Let's look into the future. This is how I would want to see the report. This kind of data could lead me to these kind of results. We should be able to visualize that before we actually do the analysis. Or else there is no question that you can ask yourself, if I give you a data set and ask you to analyze that, what is the basis for your analysis? The basis for your analysis is exactly this set of discussions that we're having. This will set the basis for your analysis. Why should I analyze this data? On which direction should I go? What are some of those subsets of problems, the meta-analysis that we want to perform? Because if we know what we want to perform, then we can start looking into either Excel or R or some other software and ask ourselves, okay, we want to perform this specific analysis. How do I do that? That's when the match happens. Oftentimes what I see with students, and not necessarily with students in this class, but also in the marketplace, is you have a data set. The first thing is just dump it into a regression and let's run the regression, and it looks really, really cool. Why did you do that? Oh, I don't know. I just thought it was cool. And that's the typical answer that you get from people who have learned a little bit of stats. That's a very, very wrong way of dealing with a problem. Okay, and we won't walk that trap. So let's start off with very simple data set. Under your Blackboard, and Nick, this applies to you as well. In your Blackboard, on the left tab, you'll see a specific tab called Datasets for this class. And within that, you'll see a folder that says Week 2 Datasets. And there are 3 datasets there, Dataset 1, 2, and 3. Open up Dataset 1. So this should be the folder, the specific data set that you want to open up. Everybody has it out? So the one that has homes, the NBHD or neighborhood, offers, square footage, brick, bedrooms, bathrooms, price. Everybody with me? So I have nothing else offered to you. I have just a bunch of home listings in a certain city that has some specific variables here. Okay, so this is neighborhood. There are 3 different neighborhoods that may have some different kind of homes in there. I have offers, and again, number of offers that a certain home has received. I have square footage. I have data on whether the home is a brick house or not. Okay, I have number of bedrooms in the house, number of bathrooms in the house, and of course I have the price of the house. Okay, so that is my underlying data. And you don't have to do any kind of analysis under any circumstance at this point, please. With data set 1, first question, simple one, identify the overarching problem. So what I want you guys to do is you can type this or you can write this, no more than one sentence, a simple sentence that encapsulates the idea of the problem, the central idea of the problem here. What is it that you can solve from just these variables? Whatever comes to your mind, write it down. It's a practice. You too, Nick. So, what do we have? Would somebody want to share what their thoughts are? Again, there is no perfect answer here. We are trying to start thinking with a mindset that has nothing to do with numbers yet. We are just looking at the variables. And we are trying to make a case as to, okay, what is this about? What is data set about? What is it trying to reach at? What is it aiming at? Sarah. Okay, so if I am a real estate agent who has this data set and I want to make it something meaningful for my purpose, that is surely one area. But that is, and this is where we are talking about the overarching problem, the 30,000 foot view, right? That is one small subset. Of course, it will come to us handy. Can we take another 10,000 foot view up and ask ourselves the same problem? Can you say that again? Sorry. The average cost per square foot in each neighborhood. And Lauren, right? Lauren says it's the average cost per square foot in each neighborhood. And yes, that is a possible area to look at, but it is again a subset of a more mundane upper view problem issue. Yes, sir. I like it. So Nicholas Davis says that it is something that dictates which home meets the client's needs from a price point. In other words, there are a bunch of variables in the data set, but all of them are kind of directed towards eventually the price. And so if I am going to help a client choose a certain home, every client is price conscious first, right? How are these other factors going to help them choose that home within that price point? Anybody else with a different angle, a different view? So Nicholas, say that again. Which home fits client needs within price point? Okay, so which home fits client needs within price point is a very broad idea here. And we'll come back to this overarching problem eventually, and we will fit in everything that the rest of you have said in bits and pieces. But very broadly, that's the way to look at the problem, right? So if we build off of that, if you recall the first video that we discussed in the context of COVID-19, right? A very broad 30,000 foot view drawing would be something that is impacting your price, right? Take a look back at your factors or the variables in the data set and come up with a nice name that would represent them all together, or maybe a couple of different areas that could be represented to impact price. So I have neighborhood, offers, square footage, brick, bedroom, bathroom. And again, this says there is no statistics to go with this, my friends. This is just, wearing the other hat. Okay, can you give a common name? Yes, Hunter. Size of the house. So size of the house includes the square footage. So bathroom and bedroom. Uh, my question to you is, can you lump, and this almost feels like an English class now, but can you lump square footage, bathroom, bedroom, brick or non-brick into a single identity? Yes, Sarah. Features, fantastic. On a very simplistic scale, that's essentially what we are looking for. So we'll say features. Is there anything else we can also add? And these are internal features, right? Sarah, location, right? So if I have to make a broad 30,000 foot view of this same problem, so let's take a look back into where we started, okay? So you look at this number of variables, and what I'm trying to teach you is a process here, okay? Before even you look into the the data points, you look at a number of variables, you just ask yourself, this is where you are the business person. You look at the variables and ask yourself, what is that underlying problem? And so, the broad idea was, okay, let's decide which house fits the client needs within a certain price point. Okay, so that's maybe the broad picture. And then to be able to formulate that in a pictorial view, in essence, you are looking into a certain set of features the house has and the house's location, and you are trying to see how that fits into the overall pricing goal. Still with me? Yes, no? So now, this is the equivalent of the discussion we had about culture impacting burden, right? So now let's look into a little bit of drilled version of the same. So this is where we draw the detailed conceptual model, okay? The detailed conceptual model is already provided to you. In this case, the data is available to you. So you still have price here, right? But let me move this stuff here. But now you can specifically put in bed, bath, brick, square footage, offers. What's the other one? Neighborhood? Neighborhood. Let me see if I'm missing something. Okay. So all of those 6 together kind of encapsulate what we just defined in the previous slide, which is a broad view of features and location impacting price. So we are going into a little bit of more detail into how bedrooms, bathrooms, whether a house is brick or non-brick, square footage, number of offers on the house, and neighborhood, they together help us understand the price point for a house. That's the problem, right? So as you can see, we started at a very sketchy level, 30,000 foot, gradually drilling down and adding more layers of complexity into our thought process. Questions so far? Yes, no? Easy enough? Okay. So the next piece of the puzzle is trying to understand the kind of variable, and we will deal with this with much greater detail the next time we meet when we talk about visualization, as well as when we bring this data set back when we discuss regression. But from a face value perspective, let's take a quick look into what the data is. So let's start with price. What kind of data is it? Qualitative, quantitative? Quantitative? Price? Based off of what has been offered to us. Okay, so this is just numbers, right? There can be any number. There is in dollars and cents. So it's very much a continuous quantitative data, right? What about square footage? Quantitative too. So that can also, right now it shows whole numbers, but it can be, in fraction or whatever. It's still square footage. Bedrooms, bathrooms. Qualitative. Um, as long as they are numbers, they can still be quantitative. Now, within quantitative, are they similar in their features like price? That's the question you might want to ask. They're still quantitative numbers. Are they similar in features to price? And they have a decimal point. The actual answer is yes. I can have 2.5 baths in my house, right? Okay, so the 2.5 bedroom I don't know about. So bedroom is very integer driven, okay, discrete. But bathroom can be still, they can be a fraction. So it's a little bit different from the price point of view from a continuous standpoint. It's not necessarily continuous. It's still discrete data, but it's quantitative. Sarah, not convinced? Okay, good. Now, that is a specialty in me that I have lost because of people wearing masks. I look through your face and I know what's happening. And that's the part I miss a lot. Um, what about offers? Qualitative? Somebody else wants to provide a different view? Could it still be? Could it still be discrete? So let me help you, because I'm seeing, and then probably now Sarah will be happier because she's still not convinced. So where is that fine line between the qualitative data, just because it's not continuous, versus calling it quantitative? With price, the kind of data prices, you can do anything and everything with it because you can form proper ratios out of that. Okay, ratios meaning that um, there is a, okay, let me ask you the question. You just wrote my quiz. Okay, so for a ratio type data, what is the deal? That ensures it's a ratio type data. The zero means something, right? Yeah. Now, for bathrooms and bedrooms, can we say that? You can. If my home has 4 baths and yours has 2, can I say mine has twice as many baths as you do? I can. What about bedrooms? Same story. What about offers? My home has 4 offers, yours has 2. Do I have more offers? Yes. 0 offers is also possible. It always happens. In this market, probably not. But in most other markets, yes. So think about that when you think on data. So they can all be quantitative data. Now, hold on to that thought. When you're talking about neighborhood, there are 3 neighborhoods, 1, 2, and 3. Even though the data is represented as if it's quantitative, ask yourself the question, without looking at the data, without analyzing the data, if you live in neighborhood 2 and I live in neighborhood 1, you are twice what? You can't say it, right? So that's where it's qualitative, even though it's represented as 1, 2, and 3. Sarah. Okay, phrase your question again one more time. Mhm. They can be qualitative depending on how you define the data. Okay, so let's say that, can we make an assumption that higher the bedrooms, higher the price? And if we can make that assumption, let's say that if it is a one bedroom house, it's a low price range house. It's a 2 to 3 bedroom house, it's a mid price range house. And more than 3 bedroom house is a high price range house. And if I can record that data into a low, medium, high, then it becomes qualitative. But as is, it's just listing the number of bedrooms. So you can always form a valid ratio between those numbers. It's quantitative data. Make sense? Does the um, does the what is it called, neighborhood concept make sense? Why it is qualitative? Of course, the brick non-brick is a no-brainer, right? So it's either a brick house or a non-brick house. Of course, it's qualitative data. And eventually, when we start looking into analyzing this data um, furthermore in Excel, we'll see that Excel is really not a statistical software. Okay, that's why you have an add-in in Excel that adds in some of the statistical qualities. If I put in this data as is in R or Stata or SPSS or Minitab or SAS or any other statistical software, it'll just do the work for me right away. With Excel, I need to train the data. Excel doesn't read break, non-break. It doesn't read yes, no. When it's reading the neighborhood as 1, 2, and 3, Excel thinks it's quantitative data. So it's thinking 2 means twice better, 3 means twice better than 1. So we need to recode that. That's a discussion for much later in this class. But right now, it's more about understanding what the data means and what the data type is. So the next piece of the puzzle is understanding the associations. And this is probably the fun part. Association between beds and price. I've already provided you the direction of association. The direction is as you see in the arrow mark, right? Higher the beds, what happens to price? This is an assumption. You are not looking at how the data behaves. This is where you are, what we are saying, hypothesizing, assuming, taking a stance, even before you have run the data and done the analysis. If your bedrooms typically increase, number of bedrooms, higher the bedrooms, what would you expect your price to be, higher or lower? Higher, right? So because if one goes high or up, the other also goes up, it's a positive relationship. So you are saying it's a positive relationship between the two variables. That's how you draw your conceptual model. Bathrooms, same story, right? Let me go past brick for the time being. Okay, square footage, the easy ones. Again, higher the square foot, you are expecting that it would be a higher price. And the fun part here is because, as we discussed in learning module 1, from a statistical standpoint, it's a very black and white. We are not looking at the gray area in hypothesizing. So keep it simple. That's the whole idea. Okay, don't start thinking, okay, what happens if it's in this neighborhood versus that neighborhood? We'll get there. Right now, when we are talking about relationships, it's only between one variable and price. We are not thinking anything else. There is a term to that. If you can read what I'm writing, it's called ceteris paribus. It means everything else remaining the same, remaining unchanged. When you are looking into the associations, we are looking into specifically the association of bed to price. We're not thinking anything else at that point of time. Specifically the association of bath to price, square footage to price. Let's talk about brick. What are your thoughts? Brick versus non-brick? If brick goes up, normally the brick houses cost a little bit more. And so you would want to go with the plus sign. Now the fun begins. offers to price. And this is where, and again, I think I have mentioned this clearly in my learning module 1. This is where the art of your design comes in. Okay, and this is where being in business school is the safest place for you. I'll say this from my experience. Okay, my wife is a biologist. Okay, she got her PhD in biomedical sciences. And if you experiment in a biology lab, you are experimenting to try and find a result. Talk about all of these guys from AstraZeneca and everywhere else who are trying to find a vaccine. What is the hypothesis? It works versus it does not work. What happens if it does not work? You go back to the drawing board and start from scratch, right? That's their life. In the business world, we have the flexibility to make a hypothesis. So I'll go back to you, and I'm still getting my names right. Amy, frame your hypothesis in terms of offers versus price. A lower price point would have more offers. In other words, it's an inverse relationship, right? So that's what Amy's stance is. So imagine that Amy runs this test, okay? And eventually, based off of the statistical test, with 95% confidence, Amy is eventually able to conclude that, oops, if offers go up, the prices also go up. So that doesn't tell her that, okay, my experiment is over, I have to start from scratch. No, that's the fun part about being in business, because that's when you ask yourself, okay, what might have changed my hypothesis? Maybe there was something else that was working behind the scenes that have changed the hypothesis. And that is the beauty of being in the business world, that you will always have an answer. We either win, as we say in sport, or we learn, we don't lose. Okay? So in the business world, it's a very similar thing with hypothesis testing. You either win, which basically says, this was my hypothesis and I was right. Or you learn that, oops, I was wrong, but I know why I was wrong. And it is still a valid experiment. Okay? So can somebody speak against the thought of Amy? Is there anybody else who is going to, Noah, not Noah, sorry, Ryan. And that is a valid thought. There is nothing wrong with that thought. It's just how you frame your hypothesis is completely up to you, the researcher. And so I would probably put that as a plus/minus. I just don't know which direction to go. I would think both directions. And you are very welcome to use either a negative or a positive in your hypothesis. That doesn't change a damn thing. You had a question, Hunter? When you say you do both, what are you asking? No, the plus/minus is only when you are unsure. When you are unsure, then you put it that way because you just don't know which way to go. Eventually, when you run the data, it will go a certain direction for sure. But normally the expectation is that, and especially for those of you coming from a psychology background, you stick to your hypothesis. Okay, so that's why I think he's asking, do you do both? No. You decide what you want to go with, and you go with that. If it doesn't work out that way, fine. It's what the data dictates, and if your results are correct, if your analysis is correct, if you're true to your data, then you will just go with the output, and you will stand corrected. And that's how this is done. Neighborhood. I have not asked you to manage the data. I didn't ask you to look at the data. You have not done any analysis. At this point of time, it's just on face value. What do you say? I would say I have no clue. And that's probably a correct answer. I would expect that they are different. That one neighborhood is probably a pricier neighborhood than the other. It's always like that. But which one is it? I don't know. Right? So that's where the question mark is. I don't know where these are headed. Make sense? So take one more look at the data set because I wanted to get into something much more detailed now. So we have neighborhood, we have offers, we have bedrooms, we have bathrooms, we have price. Okay. So now let's go back to our original model where we identified the overarching problem in terms of deciding which house fits the client needs within a price point. Can we define certain subsets of this problem? Okay. And this is where I go back to Sarah with her very first thought. What was that when I asked her to define a problem? What did you say about the neighborhoods? Okay, so neighborhood 1 versus 2 versus 3. Is there a difference? Right? So that's a subset of the broader problem, right? What are similar other subsets? Something that really stands out just by talking about neighborhoods 1, 2, and 3. Something else that's very categorical that you are trying to understand, is there a real difference? Brick versus non-brick, right? So the next sub-problem is brick versus non-brick. Is there a real difference? What else can we think out of this? Can we convolute this any further beyond these two steps? Say that again, ma'am. The number of bedrooms. So what's the question? How many bedrooms within a certain neighborhood? Is that what you're saying? Go ahead, please. So what was your thought process? Okay. Number of what? Offers? Well, those are directly also being questioned by the overall conceptual model. And all of these are being questioned in the conceptual model as well. If you recall, they are factors within the conceptual model, right? But because we have been able to identify those two subsets, can we lump them into something even more meaningful? That's my question. So if you are looking into home prices, let's say, okay, so this is neighborhood 1, neighborhood 2, and neighborhood 3. These are your home prices here on of these columns, right? And you are trying to compare those prices and see how different they are from each other. Are they statistically different, or the difference happened all by chance? Which neighborhood is more pricey than the other, and so on, right? Can we somehow incorporate brick in the mix of things? We are also doing this separately. We are doing brick versus non-brick, and we are looking at all brick houses. We're looking at all non-brick houses. So what is the next logical step about combining these two? So in other words, if you can break down the data further into brick and non-brick houses by each neighborhood, and then you can look at that data and try and understand how different are they in terms of their pricing. And then you can also connect that to a certain number of, and I think that's where Ashley was headed, that when you talk about bedrooms, bedrooms alone is a very easy standpoint from a conceptual model. But if I see that a brick house in a certain neighborhood and a non-brick house in a certain neighborhood have, let's say, very similar pricing, now that becomes now the choice of the client in terms of whether the client is looking for a brick or a non-brick house. But we can go further and see how what the bedroom count is for all of those specific houses that kind of cater to similar pricing. Because always understand, when you ever go for a house hunt, you will tell the real estate agent, this is my budget, this is my range. And the real estate agent's job is to find not one house, but multiple houses in that range. And they all have very specific features. And this is a perfect example. In this context, there are 6 different areas within which the real estate agent can design a certain house within a certain price range, and they can all fit within the same bucket. And that's what the agent's job would be, to find that right continuum of houses, if you will. One from a brick neighborhood, one, maybe another in the neighborhood 2, which is non-brick, maybe another in neighborhood 3 that's non-brick, and they have very similar pricing. What changed? Okay, that's where the square footage, the bedrooms, the bathrooms, and all of those things eventually help make the client come to a decision point. Yes, no? We have not crunched a single number, guys. And that's the beauty of it. This is where Sarah Shikora, remember you talked about being artistic? This is where being artistic helps. Okay, you think through, because now if you are able to think through this problem, then there is a logical next step. Okay, give me the power of your tools for me to crunch this data and solve something that will lead me to this kind of an outcome. You already know what the kind of outcome you are seeking. You don't know the exact outcome, but you at least have a picture of what you are seeking. Only then analyzing the data makes sense, or else you are kind of in the dark, right? Yes, no?